Hello everyone, my name is Elena, and today I am presenting my interpretation of the machine learning workflow for the Avalon age prediction assignment. I find this particular case study incredibly relevant to how we apply the data science to solve the industrial inefficiencies. And the core business problem here is that determining the age of an abalone currently requires a laborious manual process of counting shell rings under a microscope, which is simply not scalable for a modern seafood market. So by interpreting the code provided, I will explain how we can replace this manual counting with a predictive model based on easily measurable physical attributes like length, diameter, and weight. So I want to start by talking about the important pre-processing and exploratory steps for data. So as we can see here, there are 4,177 rows in the data set. And the first quality checks reviewed no duplicates or missing values, providing us with a very clean starting point. And a very distinct pattern about feature relationships became apparent when examining the exploratory data analysis through the AutoVis outputs. So significant multicollinearity is indicated by this heat map, exceptionally high correlations, particularly the 0.99 correlation between the length and diameter. And this implies that those dimensions offer the redundant information, even though they are predictive of age. And as a prerequisite for any regression algorithm, I observed that the code converted the categorical sex feature into a numerical format using a label encoder here. And in order to prevent the extreme data points from disproportionately pulling our regression line and distorting our final predictions, it was also essential to apply the Tucky rule here to find the outliers in the target range variable. However, the most insightful visualization for the business stakeholders is the feature importance plotted by generated by the random forest model. So it clearly identifies the shell weight as the most significant predictor of age, followed by other weight measurements. And this is a key finding because it suggests that in a real-world aquaculture setting, simply weighting the shell after processing can provide a highly accurate proxy for the maturity of the harvest. And then moving into the modeling results, the instructor codes allows us to compare the several algorithms, which is essential for understanding the bias variance trade-off. So for this assignment, we focused on the multiple linear regression as our baseline and compare it to the tree-based and neighbor-based models. So to ensure the results are valid, the data were split into an 80% training set and a 20% test set. So this validation method is critical because it prevents us from simply overfitting to the training data. And it shows us exactly how the model will perform on new unseen abalone samples. And we also applied a standard scalar here to the features, which is particularly important for the multiple linear regression and KNN model to ensure that the features were with larger numerical ranges like weight and grams do not overshadow the smaller measurements like lengths in millimeters. And we can see the multiple linear regression model obtained an R-square of 0.53 when analyzing the particular performance matrix. And this indicates that the physical characteristics in the model accounts for roughly 53% of the variation in abalone age. And it's really interesting to note that the lasso regression performed noticeably worse with an R-square of just 0.14, whereas the ridge regression yield identical results of 0.53. And this disparity in performance serves as an example of the trade-off between the bias and variance. And by over-penalizing the features, the lasso model probably introduced too much bias, resulting in an underfit model that was unable to adequately capture the complexity of the data. And with an R square of zero point 0.5 of the KNN model, I think the KNN model and also the multiple linear regression model appears to have struck a better balance, capturing the overall trend without becoming unduly sensitive to the noises. So I think this finding have significant practical ramification for the seafood sector. Although the model's error rate indicates that there is still some natural variability that a straightforward and linear model cannot fully capture, and the patterns indicate that the physical characteristics are in fact powerful indicators of age. But there is no denying the increase in efficiency. And a company could automate the maturity assessment of thousands of ablones in a matter of seconds by using a model such as the random forest or the multiple linear regression exam here, which would also like take weeks for a human to complete. And better profit margins are more environmentally friendly practices result from this. So I hope that this analysis of the code has made it evident of how effective the machine learning workflow is at resolving the conventional business problems. Thank you for listening.